Very good afternoon to all of you. This is P. Venkesh from Sri Vishnu Engineering College Permanent, Department of Civil Engineering. Today I am discussing the topics of how to design the rigid pavements for the low volume of the roads. For the design and the guidelines of the rigid pavements of low volume roads, IRC give these specifications. The code book is IRC Special Publication 62 to 2014. Under the contents was introduction, scope, factors governing design, design of slab thickness, joints, material and mixed design construction. We take the introduction part. IRC give the some special publication 62 for the design of the cement concrete pavements for the rural roads, the 2014. These are the members having the committee for the designing, for the forming of the guidelines. So these are the additional members to form the guidelines and give the instructions to the design of rigid pavements. In the rigid pavements, all over the India, we have the more of the roads having the less vehicles traveling for the day, and that have this connected to the cement roads. So in that, cement concrete pavements have been constructed on many rural roads under PMGA-S5 programming. They are also being widely used on minor roads of cities carrying low volume traffic because of durability, even under poor drainage condition. Concrete pavement offers an alternative to flexible pavement, especially where the soil strength is poor, the aggregates are costly, and drainage conditions are to be considered. The choice depends upon the life cycle of the factor, cement, concrete, commercial care, and also that concrete depends upon the self-concrete. Under the scope, the rural roads connecting major roads are sometimes required to carry construction or diverted to traffic with damaged concrete slabs. Some roads connected to several villages and they may be constructed in stages spread over the several years. It should be recognized that the concrete pavement demand is high degree of professional expertise at the stages of the design. Finally, IRC 58 deals with the design of cement concrete pavement of major roads carrying an average daily traffic exceeding 450 commercial vehicles per day, with laden weight exceeding 30 kilometers. The guidelines contained in this document are applicable only to low volume roads with an average daily traffic less than 450 commercial vehicles per day. The basic design concepts of IRC 58 may be relevant for arriving at pavement thickness. In the case of for the design of rigid pavements for low volume roads, the first to design factor is wheel load. We should have to take the wheel loads for the 100 kilonewtons for the single wheel load. Next one is the tire pressure. We should consider the tire pressure taken as 0.05 MPa. Next one is the design period. In the design period, we have take 20 years or higher evidence from the design. The design methodology given the guidelines based on wheel load stress. Next one is design traffic or thickness of evaluation. For the determination of the thickness, it will the number of the vehicles takes a major role. Traffic less than 50 commercial vehicle per day. Only wheel load stresses for a load of 50 kilonewton and dual wheel load need to be considered for thickness estimation. For traffic higher than 50 and less than 150 CBPD, thickness evaluation should be done on the basis of total stresses resulting from wheel load of 50 kilonewtons and temperature differential. Considering next one is a design traffic for the thickness of the evaluation. For the thickness of the evaluation, they can give some empirical formula. These are the terms explained here. The characteristics of the subgrade. The characteristics of the subgrade expressed in the terms of the modulus of subgrade reaction K, which is also known as the soil test, which is determined by carrying out a plate bearing test using 70 mm diameter, where we can use the 750 diameter according to IS specifications. In case of homogeneous foundation, test values obtained with a plate of 300 mm diameter K may be converted into given say 750. This correlation is given K75 is converted to the 0.5 into K30. The approximate K value corresponding to the C value are given in the table 3.1. The case of characteristics of grade. The factors for designing subbase. The subbase have the following conditions. It provides uniform and reasonable support. It supports construction traffic. It prevents mud pumping. It acts leveling forces. Next one is subbase. The subbase having the variation in the traffic. If it has the traffic up to 50 commercial vehicle per day, 75 mm thick compacted waterborne macadam wet mixes may be provided over 100 mm granular subbase made up of granule, morum or river bed, and with 30% liquid limit not less than 35%. Traffic from 50 to 150, 75 mm thick waterborne macadam layer 100 mm granular material may be used as a surface. Alternatively, 100 mm thick cementitious granular material may be used for that one. So these are the different types of the low volume or traffic conditions. Based on that, we can decide at the traffic thickness of the pavement. If the traffic is from 150 to 450, 150 mm thick waterborne macadam over 100 mm granular surface may also be used. Alternatively, 100 mm cementitious granular layers may be used. The design of the slab thickness, for the designing of the slab thickness, we can consider the different types of the stresses onto that. That the first one is critical stress combination. For the analysis purpose, two different regions in pavement slab, that's edge and corners, are considered. Critical for the pavement design. Effect of temperature gradient is very less at the corner, while it is much at the edge region. So we have to consider the edge and the corner regions for the critical stress combination. During the day and night light, the pavement will be like as a, the case of during night. In the case of the during the day, the tensions is at the form at the bottom side. At the night side, the tension will be formed at the top side. These two are formed because of the variations in the temperature and that local conditions. For the design of calculation stresses, we should consider the edge stresses. That edge stress is calculated by the mathematical equation. By using all the parameters, stresses at the corner, deflection at the corner, we can determine. So these are the various terms used for the calculation of that one. Next one is temperature stresses at edge. At edge, we want to calculate the what are the stresses developed due to the temperature, that they can given by this some empirical formula, where the T value is differ from the one place to another place and depending upon the thickness of the slab. These are the table 4 recommended temperature for the different values. Pavement design. For the pavement design, we should consider the following three cases. In the case 1, stresses due to 150 kilonewton dual wheel load. In the case 2, combined stress due to 50 kilonewton dual wheel load and temperature gradient for traffic greater than the 150. Case 3, fatigue analysis for stresses due to 50 kilonewton dual load and temperature for the traffic greater than 150 cp/cd. For the designing of the pavement thickness, we can consider all these three conditions. So these are the recommended designs procedure for the rigid pavements. Select design below. Alternative design thickness. The total traffic is less than 50 cpd. We can consider case 1. If the computed edge stress is less than 75 modulus, if the traffic is greater than 50 cpd, we can consider less than 50. We can take it as case 2. Recommended design pavements is the like that. If the traffic is more than 150, we can consider the case 3. Pavement thickness for traffic up to 150 c. Depending upon the traffic conditions, we can assume or we can take the trial thicknesses. A subbase of 75 mm waterborne over 100 mm GGBS is considered. The thickness value for dual wheel load is 60 kilonewton or 160 mm for all the joint spacing 2.5 mm. So next, pavement thickness for traffic up to 50 to 150 cpvd. From the table 4.2 gives joint spacing and depending upon the pavement thickness related to the zone 1. So if we take the joint spacing 4 meter, if we take in the zone 1, that is 150, by varying the spacing joint, the thickness of the pavement is also varying. Pavement thickness for the greater than the 150 cp. Similarly, again here the thickness is varying. Thickness is varying depending upon the spacing of the joints. Next one is the roller compacted. After the laying of the concrete, there are different types of the compacted, that is the roller compacted or sulfate compacted. So for the construction and the proper laying of these rigid pavements, we should have arranged these type of the construction in order of the proper execution of the rigid pavements. Construction, expansion, longitudinal joints. These are the required joints for the proper execution of the rigid pavements. So these are some diagrammatical representation of the above all the joints and their spacing according to IRC 62 special publications. These are the joint spacing and how we can provide this one. So these are some placing of the formwork, how to arrange the formwork, how we can place the compacted one. These are the construction joints. And after that formwork is completed, we have the mixed design. That mixed design consists of the cement, aggregates and sand. For the mixed design, we should have all the material should be selected according to the good quality of the material. If it is fly ash, we may be use some quantity of the fly ash for the partial replacement of the cement. These are the specific properties of the fly ash. Next, aggregates. We should have selected the aggregates which satisfy the uh, all the requirements of the mixed designs. In that fine aggregates, we can have follow the some important points to be satisfied. After that, mixed design, we may be provided the roller compacted concrete pavement. In the case of concrete, the compaction may be by the vibrator self-compacting, the design mix. Finally, after selecting all the materials in the proper order, that laboratory trial mix shall be carried out in the field out. By conducting the number of the trial test, we can design the parameters. These are the construction. First, we prepare the sub base. After that, construction of the trial and bashing. These are the step-by-step procedure for the construction and laying of the cement concrete pavements. If we take the example, cement concrete pavement, if we take the one example for the design of the low volume rigid pavements, that example is cement concrete pavement are to be designed for rural roads in Uttar Pradesh having traffic volumes 45 CPBD, 140 200 commercial vehicle per day against vehicles like agricultural tractors, trailers, light good vehicles, heavy trucks, these buses. The soil has a so-called CBR value of 4%, 75 mm waterborne macadam grade 3 and over 100 mm GB. These are the given conditions. For the design, first we can take it as design wheel load 50 kN, type pressure assumed to be 0.50. From table 1, the K value corresponding to CBR is 35 MPa. First we can assume subbase is 75 mm thick waterborne macadam over 100 mm GSP. For the effective of the K value, we may be provide the 20% additional to that according to the given codal provision. The K value is 1.20 factor, that is 42 MPa, and minor K value is little effect on the stresses. For the concrete strength, for the determination of the concrete strength, we have followed the equation 28 flexural strength, 90 days flexural strength. For the design of traffic for 48 CPA, at trial thickness, I can assume a 150 joint spacing 375 by providing the trial thickness and which is not satisfied for the K value. So this is trial value is not satisfied. In the second case, I can take it as K equal to 70 MPa and the design load is 50 kilonewtons, which will satisfy the design criteria. Total thickness is 150 for GBA GSP. At trial thickness of 150 mm, joint spacing 3.75. Temperature differential for UP, Uttar Pradesh, zone number 1 from table point. Granular subbase. The total wheel load and the temperature stresses due to 50 kilonewton dual wheel load is 4.25, which is greater than the required one. If the joint spacing 2.4, the stress is 3.64. Hence, the design is safe for 150 mm slab. For the joint spacing 3.75, increase the thickness up to 150 mm, complicate the stress. So again, that condition is also again satisfied. Finally, we can adapt it for granular subbase 150 mm width and 3.75 joint spacing. And the cemented base, the temperature curling stresses can be reduced by adapting lower joint spacing while the loads are reduced gradually. Where K is 150 and 150 when cement is subbase, trial thickness 170 to 3.75 spacing. Stresses are in the less than the safe. Design have to factor selecting the all joint spacing. These steps can be created a shorter joint spacing. A pavement design for the 200 commercial vehicle per day. In that design life is 200. Assume a trial thickness of 200 mm and joint spacing of 4 meters or 250 mm GGBS. The cumulative fatigue damage is 190.31. Hence it is unsafe. It should be always less than assume to a joint spacing 2.1. By reducing the joint spacing, in the second case, we can get the 2.4 mm. In the final stage, the total thickness is 220 mm for 4 meters, 4 mm joint spacing. Pavement itself unsafe, hence the cumulative fatigue is 9.62. Consider a joint spacing 2.5 meter. The pavement is safe since the cumulative fatigue damage is 0.01. So up to we can try assume the trial thicknesses for the reduction of the fatigue damage is less than 0.01. Finally, we can give the thickness of the rigid pavements. Thank you.